Hello fellow game makers and welcome to the second part of the Shadertoy shader adaptation underwater effect creation tutorial. In the first part of this tutorial, we have created this nice Godray effect that simulates the light falling through the ocean surface. In the second part now we are going to slap the wave distortion effect on top of that. Even though it will be quite subtle, we are still going to slap it on there. And this will be another Shadertoy shader, so the first step will be to have a look at what Shadertoy has to offer. And I found this nice and still quite simple wave distortion effect. It looks a bit rough right now, the waves are quite large, but if you look in the code here, you can already see that there are values, parameters that you can adjust, like the speed and the X and Y distortion. So this looks like it will be a very adaptable shader. There's also this variable up here, show how it is done, and if you set that to 1 and recompile the shader, there is a mode built into the shader that shows you how the X and Y distortion is added together to distort the final image. So later we're going to take all of those parts out of the shader because we don't need them in our game in GameMaker. Also, you can see that the shader now has input channels here, textures that it uses to show the picture on the screen. And that's the big difference between the Godray shader and the wave distortion effect here. The Godray shader was completely self-contained. The whole image that it created in the end was produced within the shader. And the water effect shader will need an input texture that it then can mess around with and shift the pixels around and then output the new distorted image. So whenever we come across these images in the code, we will need to replace them with the texture that we want to distort in GameMaker. However, I need to be a little bit more precise. This channel 0, this is the checkerboard texture that's only used for this behind the scenes mode where you can see how the effect is created, so we don't even need that. But this channel 1 picture, that is the picture that is being distorted by the shader, and you can see down here, this is where it is used in the code, and that is where we are going to have to change it in GameMaker to the input texture that we want. But the first steps are the same as before. We start by copying the whole shader. Also, don't forget to copy the inputs up here. Now we can switch back to GameMaker and create a new shader. I will go through those first steps a little bit more quickly because you can look them up in part 1 in more detail. I'll call that shader underwater. And in the fragment code we're going to delete what is already in there and instead paste in the new code. As you know from part 1, the first thing that I do is to just reformat the code so that it matches my style of coding, so I'll be back in a moment. So here is the shader code in GameMaker after I have reformatted it. And as I've said, you can see that there is this variable show how it's done. And later in the code you find these if and ifs, where if show how it's done is true, there is some code being performed that is only used to look behind the scenes and see how the effect is created. So we can get rid of this variable, and we'll also have to then get rid of all the parts in the code where this variable is used. So for example from here to here and also down here, which means that we can also get rid of those two brackets. And I can already see that this blue shift to make it look like water is not something we need because we already have a blue background resource, so we can also get rid of that code. Next, you remember that frag color is not the variable that GameMaker uses to output the final image. So we need to change that to GL frag color. Next, we need to make sure that we create the variable frag chord. We do that all the way up here. varying vec2. We have to do the same in the vertex shader, and there we also have to define it as the in position.xy. Next, we have to go through this list of parameters and see which ones the shader actually uses. I can already tell you that it only uses the resolution and the global time and one of those channels. This is the input texture that the shader needs to distort the image, and we'll talk about how to create that later on. For now, we can get rid of it and only leave those two parameters up there. Finally, we need to adapt the main image method, which is not used in shaders in GameMaker, and replace it by void main. So those are the basic adaptations that I've also shown you in part 1. Let's see what the compiler has to say about the shader as it is right now. The compiler complains that we modify the varying frag coord. And that's something that we are not allowed to do in GameMaker. So let's have a look at that. This is the line that the shader doesn't like, and also the one up here. These are lines where the frag coordinate, so the coordinate of the current pixel that's being worked with, is directly modified. That's something that works in Shadertoy, but not in GameMaker. So the simple solution is create a new variable, feed it the frag coordinate value, and then just use that to manipulate it. So let's create a new vec2. Let's call it UV, and we'll just set that to the frag coord.x and the frag coord.y. So it's really just a copy of the frag coordinate variable, but it's called UV, and if we change the instances where the frag coordinate is directly modified and replace it with UV, we'll actually get rid of that error. We also have to make sure that in the end, when we use the frag coordinates to draw the final texture, now we also have to replace that with the UV variable, because that's the one that we modify and distort, so we'll have to change that down here as well. Let's have another look at the compiler. There's some stuff going wrong in line 66, and it all starts with this iChannel1, because that's an undeclared identifier, and that's correct. We have just removed it from the parameter list. That is the texture that we need to feed the shader in order to do its distortion calculations. So we'll have to reintroduce that now. And I'm not going to call it iChannel1, but I'll call it text_water, so that I know that's the texture that contains the water image. And up here, we have to now create a uniform sampler 2D. This sampler 2D is what GameMaker uses to store textures in shaders. And we'll call that text water. Let's have another look at the compiler. Okay, we have no more compilation errors, and that means that we can now start implementing the shader in our code. Let's switch back to our VFX object, and in the create event, we will have to, as we did with the Godrays, we'll have to catch the shader uniforms that we have created so that we can later access them and modify them. So let's just copy those two lines because they are basically the same for the underwater shader. Let's change the shader source to shader underwater. The names of the uniforms within the shaders is the same, so we can leave that as it is. However, we can't use the same names in our code for the two pairs of shader uniforms. So we will just add _water to the second pair. Also, in addition to these two uniforms, we also need the third one, which is the sampler. We'll call that u_texture water. And since this is a sampler 2D, we can't use the method shader_get_uniform, but we have to use shader_get_sampler_index. Again, we supply the shader and the uniform name, which was text_water. And now we can access and fill this texture with an image later on. So let's have a look at the post draw event where we are going to add this effect. Right now we draw the application surface and then we draw the Godray shader on top of that. We will have to modify that a little bit because we don't want to draw the application surface directly anymore. We want to feed the application surface into the underwater shader, let it do the distortion, and then draw the distorted final image to the screen. So we can actually comment out this first line because we're not going to draw the application surface directly anymore. Instead, let's prepare the code for our underwater shader. Everything that stands between these two lines is affected by the water shader. And again, first things first, we're going to set the shader uniforms. First, the resolution of the water shader, then the time variable of the water shader, which is the current value of the variable sec. You can look at part 1 again if you need to know what that means. And now comes the important part where we feed the current application surface that holds all the backgrounds and all the sprites and everything that we want to be modified by the wave effect. And we need to feed that into the shader. The name of the method to do that is a bit strange. It's called texture_set_stage. First you have to supply the sampler ID that is used in the shader. So that was texture_water, and now you have to supply the texture. You could supply a sprite, you could supply a background resource or a surface. In our case, we want a surface. We want the application surface to be the texture that is modified by the shader. So we call surface_get_texture for the application surface. Now we have fed the application surface into the shader, and now we need to draw something to the screen so that we see the final modified image that the shader has produced. It's important to understand that we don't have to draw the application surface. We just have to draw anything because the shader will do the image calculations internally. It will just need something like a canvas where it can paint the result onto. So it's enough to do the same as we did down here and just draw a rectangle that has the size of the full window. And this will then be filled by the color information that the shader has produced. Let's have a look whether those modifications were actually already enough to create the wave distortion effect. As you can see, the wave effect works. It's quite big right now, but it works. But something strange is going on here. It looks like our texture has been squeezed into a square form, and that means that to the right here we have some area without any texture information, and it just stretches the image weirdly. So let's have a look at the shader code again. What's happening here is that this line messes with the texture. For whatever reason, there is a line in the shader that ensures that the entire texture fits into the view. So these two lines here, this one and this one, make sure that the texture is squeezed so that it completely fits into the view. We don't want any of this scaling to happen. We just want the complete texture to fill the screen. So what we are going to do is to get rid of this code here and introduce one more line where we change our UV variable to frag_coord.xy divided by iResolution.xy. With this line we make sure that the image always fills the complete window that we are drawing to, and the resolution of that window is stored in this iResolution variable. Right now it's 800 by 600. Let's have a look at how that has affected the image. It looks better now. The whole image fills the window, but you can see that the wave effect is so big that the distortions actually show us some of this unwanted stretching here. But that's very easy to get rid of. Now we just have to start fiddling around with the parameters, change the X and Y wave size in order to get the effect subtle enough to still be visible, but not to produce any visual artifacts here. So I've played around with the values a little bit, and I decided to increase the speed to 3 and change the X and Y distortion to 0.00125, so much smaller waves than before. And also changed this value here. That was a bit difficult to figure out. I'm not exactly sure how that works. That was just me trying out different values, and that produced a nice end result. Let's have a look. So you can see that we now have nice small wave distortions. You can also see that they are applied to the fish and everything that is on the application surface. And on top of that, we draw the Godray effect, which in combination, I think, really creates a nice underwater effect. At this point, we could be done with the tutorial, but there is one more thing I want to at least point out to you. And that is, if we have a look at the manual in GameMaker and have a look at the surface create function. It tells us that it is highly recommended that all surfaces be created with a power of 2. And it's not necessarily needed for platforms like Windows or Mac, but certainly increases the compatibility. Well, what does all of that mean? The problem is that we are using the application surface to create a texture that is used by the shader. The size of textures should be a power of 2, like 1024 by 1024. Right now, the application surface is 800 by 600. It could happen, in theory, that on older graphics cards or on targets like HTML5, that creates unwanted visual artifacts because those target platforms or the graphics cards can't deal with textures that are not a power of 2. So let me show you at the end of this tutorial how you can make sure that the texture that you feed into the shader is always a power of 2, even though the source, like for example right now, the application surface, is not necessarily a power of 2. What we need to do for that is to create one more surface, a new surface. So in the create event here, let's create a surface called surf water. And we'll create that to be 1024 by 1024. Why? Because that is the next bigger size that is a power of 2, and that's bigger than our current application surface. Our application surface is 800 by 600, so we need 1024 by 1024 to get the next power of 2. In the post draw event now, we will have to make sure that this surface actually exists and that it is filled with the application surface. So if the water surface does not exist, we'll actually have to create it again. And now we have to fill it with the application surface. But the application surface is 800 by 600. The new surface is 1024 by 1024. So what we need to do is we need to draw the application surface into this water surface stretched so that it fills the entire square water surface. We do that by calling surfaceSetTarget. To make sure that we now draw to our water surface. And now we draw a surface, but we draw it stretched. With this method, we can supply the ID of the surface that we want to draw. This is now the application surface. We want to draw it at coordinates 0, 0 to our new surface, and we want to draw it stretched to 1024 by 1024. Finally, we can reset the drawing surface. With these lines, we have now transformed the 800 by 600 application surface into a square power of 2 texture. And now we only need to change this line down here, where we feed the texture into the shader. And instead of feeding the application surface directly, we now feed our square water texture. Well, you will ask, doesn't that draw the water distorted because we've now stretched it to 1024 by 1024? Yes, but this distortion is reversed when we use the shader to draw the rectangle that's 800 by 600. And remember, in the shader, we now have the code here that always makes sure that the output resolution, which we've set to 800 by 600, is modifying the frag coordinate, which could be 1024 by 1024, and makes sure to break that down to our current resolution. So in the end, we shouldn't see any differences. And as you can see, the wave effect is still there. The fish also still get distorted, but this way of squaring the texture and then feeding it into the shader increases the compatibility on targets like Android or HTML5. So guys, that was it for this set of tutorials, and you've learned two things. You've learned how to adapt Shadertoy shaders for use in GameMaker, and you've also learned how to create quite a nice underwater effect. In the next set of tutorials, I'm going to have a look at another source for shaders on the internet. This time we're going to focus on transitions, for example, room transitions. So for the time being, enjoy your underwater effect, and then see you soon.